Hey Mr. Fies, I hope you're having a great day. I'm Emily Shrimpton and this is my video for the project. So Newton's law of cooling. In order to determine the time of death of Mr. Fies, one must use Newton's law of cooling. However, before jumping straight into finding the time of death, one must find K, the decay coefficient, so that will be what our first equation is, finding K. Okay, so I wrote out the equation for Newton's law of cooling. And so to find the value of K, we are going to be plugging in our given temperatures into this equation. Okay, so as we can see, one can set 75 degrees Fahrenheit, which was the last recorded temperature, equal to 70 degrees Fahrenheit, the constant room temperature, and therefore our ambient temperature, plus the solution to 80 degrees Fahrenheit, the temperature of the object, minus 70 degrees Fahrenheit, the constant room temperature, and therefore our ambient temperature, along with e raised to the negative k, which is our decay coefficient, or the variable being found, multiplied with 60 minutes, which is the time elapsed between the two changes in temperature. So now from that equation, we just use basic rules of algebra to solve and isolate K. So I did some combining like terms, the subtracting, dividing, everything that I need to do to get to the point where I can get K alone. However, it gets to a point where in order to find the final step of isolating K, we must apply the natural logarithm to both sides of the equation to cancel out e, and finally K is completely isolated and the value is found to be 0.01155245301. So now the time of death, or at least the time elapsed since death from discovery, can be found. So once again, this side. Once again, we're going to be using Newton's law of cooling to find T, which is the time elapsed. Okay, so here we go. I wrote the equation out again, and in order to find it, we set 80 degrees Fahrenheit, the temperature of the object upon discovery, equal to 70 degrees Fahrenheit, the constant room temperature, and therefore our ambient temperature, plus the solution to 98.6 degrees Fahrenheit, which is the average normal body temperature of a living person, and therefore our temperature at time of death, minus 70 degrees Fahrenheit, which once again is the constant room temperature, therefore being our ambient temperature, and along with e raised to the degree of what we just found to be K, which is negative 0.01155245301, which is our decay coefficient, multiplied with T, which is what we're trying to find. It is the time elapsed between time of death and time of discovery. So from that equation, once again, we just use basic rules of algebra to solve and isolate T. So as you can see, once again, I did that. And then we get to that point again where we need to apply that natural logarithm ln to both sides of the equation to cancel out e and further isolate t. And so we get to that point, and we're able to find that t is 90.9609081 minutes. And so from there, knowing that time that has elapsed from time of death to time of discovery, which in tenths of an hour is 1.5 hours, one can count back from 6 o'clock p.m., which was the time of discovery. So that is what I did. Our final step was finding that time of death, and knowing that our value for t is about 1.5 hours, I went from time of discovery, which is 6 o'clock p.m., and I counted back an hour and a half to 4:30, and 4:30 is therefore our time of death. So in conclusion, the time of death of Mr. Fies was determined by his declining temperature over time from when his body temperature was at an average 98.6 degrees Fahrenheit at his time of death, and its gradual declining rate over time from when his body was discovered and onward as the hours passed. The value of K is 0.0115524530. The value of K is, I'm sorry, I already said that. So therefore, knowing K and what it represents, which is the decay coefficient, it is also the ratio of the amount being lost over a given period of time, in this case temperature. We know that the time elapsed was 90.96090,881 minutes. However, to the nearest tenth of an hour, the time was 1.5 hours when determining time of death to time of discovery. The approximate time of death was therefore 4:30 p.m., and the time of death was therefore once again determined by counting back that hour and a half from the time of discovery being 6 p.m. So that is my video. Thank you for watching.